Okay, let's end this section by talking about geometric series. With the common ratio, it's called R. So geometric sequence I mentioned, AN equals R to the N. That's an example of a geometric sequence. You could have a constant A in front of that. It's still a geometric sequence. So definition, the series, the sum from n equals 1 to infinity of a times r to the n minus 1. Doesn't really matter that the exponent's n or n minus 1. Doesn't matter. We'll use n minus 1 here. Is called a geometric series with ratio r. By the way, be able to recognize a geometric series, at least an easy one, when it's written out longhand as well. So if the first term is a, or a1 if you like, then how do you generate the next term? Recursively thinking, to get the next term, you multiply a1 times whatever r is. And then to get the next term, you multiply that a1 times r, so this would be a3. You multiply a1 times r times another r, which would give you r squared. To get the next term, you multiply a1 times r squared times r once again, and that would give you a1 times r cubed. So the first three terms of the series would look like this, and if you write it out, you just have to put a dot, dot, dot there. So that's what it would look like if you write it out longhand. And again, I used a1 here, so I'll use a1 there. Okay? So how do you, if it were written out just longhand, how would you recognize or test really whether or not it's geometric? You could divide any term of the series by the previous term, and if it's geometric, you'll get r. You'll get, well, r will be a specific number for any given series, but you'll get a constant number there. The common ratio we call r. So if you divide a1 times r by a1, of course you do get r. If you divide a1 r cubed by a1 r squared, you'll get r as well. Take any term except the first term, I guess, and divide by the previous term. If you get a constant number, the same number every time, you know it's a geometric series. Theorem: an infinite geometric series converges to, dun, 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 dun. You may remember from pre-calculus, it converges to a divided by 1 minus r. And what we can call that the sum S. You can find the sum for a finite geometric series, which we called Sn earlier. But you can find that the Sn is given by the formula a times 1 minus r to the n over 1 minus r. That's the sum of the first n terms. And then if the absolute value of r is less than 1, which means really, if you want to drop the absolute values, it means r is between -1 and 1. R is a proper fraction. Then Sn, so this is, think of this as the nth partial sum. And the sum of the infinite series, n equals 1 to infinity of a times r to the n minus 1, is the limit of that thing, the limit of Sn, as n goes to infinity. This is by definition. So Sn is, if you believe that, it's the formula a times 1 minus r to the n divided by 1 minus r. And then what's that limit equal to? If r is between -1 and 1, what does r to the n go to? This is one thing we talked about yesterday. What does the sequence of r to the n go to, represented by r to the n? What does that go to? If r is a proper fraction, like a half, and you keep raising it to higher and higher powers, it shrinks to 0. So if this condition holds, then, you just get a times 1 over 1 minus r. You get exactly what we said. But it only works if r is between -1 and 1. It diverges otherwise. Okay? So that's a good note to make. It diverges otherwise. Diverges otherwise. Okay, does that seem reasonable to you? Okay, so let's close it out by looking at a couple of these. Does it converge? If so, find the sum. The sum from n equals 1 to infinity of 1/3 to the n minus 1. Okay, is that an infinite geometric series, first of all? Yeah, anytime okay, here's the main way to identify it if it's in summation notation. This formula for an will be an exponential function. And the exponent has to be like n to the first power, and it could just be n or n minus 1 or n plus 1. If that's the case, you could have a constant factor out front, that's fine. If that's the case, it's going to be geometric. If so, find the sum. So yeah, it's geometric. What's r equal to?
1/3.
It's the base of the exponent. That's a good way to remember it. It's always the base of that exponent. Okay, it's good to note that it does or does not satisfy that condition of the absolute value of r being less than 1. Does it satisfy that? Yeah, 1/3 is definitely in between -1 and 1. That's a big old check mark. So we can just find the sum of this thing using the formula. So you're going to want to memorize the formula. You've probably had to memorize it before, but just write it down a few times. S equals a over 1 minus r. Write it down a few times in the homework. You'll get it back in your brain. Hey, remember, a is the first term in the series. So how would you get a using the series notation? Using the given series, how would you get the first term? What do you plug in? You plug in whatever the starting value for n is. If it's 1, you plug in 1. If it's 0, you plug in 0. In this case, it's 1. So what do you get when you plug 1 in there? So a equals 1/3 to the 1 minus 1, which is 0 power. So you get 1/3 to the 0, that is, which is 1. Okay, plug and chug into the formula. What do you get for s? 1 over 1 minus, what's r? 1/3. Oh, just a little bit of algebra here. We can handle that. That's 1 over what? 2/3, which is 3/2. Hey, that's one of the easiest problems you've seen in a while, right? It's not so bad. Can you guys do part B for me? Just keep yourself awake. So this would be a nice format to follow. Find r first and note whether or not it satisfies the condition. Because if r is bigger than 1 or smaller than -1, you're done. It diverges. Right? So do that first and then apply the formula a over, you got to find a and then apply the formula a over 1 minus 1. By the way, it doesn't matter that the exponent isn't n minus 1. It's still, if you write it out, it's a geometric series because you're going to multiply it by -3/4 to go from one term to the next term. That's all that really matters. If you're multiplying by that constant ratio to go from one term to a next term, it's geometric. You guys getting an answer? Any brave soul want to offer their answer? Yeah, I know, and we get all upset if we offer a wrong answer. That's why nobody wants to offer. I'm wrong all the time, you guys. Don't be afraid to be wrong.
8/7?
I have no idea. Is it 8/7? Do I have agreement? That's what you got. 2 people. I don't know do we have to have more agreement. 3 people. Now I'm starting to believe you. All right. So what was r equal to? -3/4. And does that satisfy the condition that it lies between -1 and 1? Yep, big old check mark. What is a? You're going to need a, like we did in the last one. You're going to need a to use this formula. So what is a?
2.
So yeah, you're going to plug in 0 here, which makes this -3/4 to the 0, 1. So a is definitely 2. Does everybody see that? Okay, so then you plug it in. What did that look like? Plug it in this formula. If you need to, write it down every time you use it. What do you get?
2 over 1 minus 3/4, or plus 3/4.
Which is the same as 1 plus 3/4. So what is that, like 7/4 in the bottom? 4/4, 3/4, 7/4. Okay. Flip and multiply, I believe it. It's 8/7. So try to wrap your brain around this. If you could add an infinite number of terms, we're saying you'd get a finite number, 8/7. Isn't that crazy? It's crazy that our minds can even think about that. I can't think of any other creature that can think about infinity or really think very much anyway, right? I suppose apes can think a little bit, right? And whales maybe, I don't know. But I don't think they're contemplating infinity, right? When they're making the whale noise. Woo! I don't think they're talking about, maybe I'm wrong. Maybe they're talking to other whales about infinity, but I'm guessing no. I'm guessing no.